LeetCode problem number 973, k closest points to origin. So this problem gives us an array of points where the points is made out of x and y, which represents a point on the xy plane, and it also gives us an integer k where we have to return the k closest points to the origin 0, 0, right? And this is just the equation to get distance. We can return in any order, and the answer is guaranteed to be unique, right? So to break it down, it gives us 2 points. We measure the distance, and we get the closest one to 0, 0. And how much we have to return depends on k, right? If k is 1, we have to return 1. And if k is 2, then we have to return 2, right? The closest 2, basically. That's it. Pretty straightforward. So what I've done is I'm using a priority queue where I'm using a pair of an integer and a vector integer, right? So this integer will be used to store the distance from the points to the origin, and this vector will be used to store the actual points, right? So this is what will be put into the output and to be returned, right? The points are what we want, not the distance. So for every points inside the points, okay, let me give a example. I'll just use this because it's good enough, right? Okay, so let's say we have points 1, 3, and 2, 2. First, I push my priority queue. Okay, I need to push 0, 0, 1 times 1 plus 3 times 3. Right? So if we break this down, this will be 9, this will be 1, 1 plus 9 is 10. And then I'm also pushing the points, right? Like this. Okay, so this is the entry. And since this if statement checks if our size is more than k, we will pop it, right? In this case, it's not. We have 1, so it's not more than k. So we move on to the next point, which is -2, -2. Again, we push again, times -2 plus 2 times 2. Right? This will give us 4. This will give us 4. This will give 8. Right? So this will actually be below the 10, because remember, a priority queue will sort it in the container itself by the highest to the lowest, right? 2, 2, this is the point that we'll be pushing over here. And since now the size of the priority queue is more than k, which is 1, so what we have to do is to pop it, right? So when we pop, we are popping the bigger, the further distance away from the origin, which is the 131. So we pop this, and after that we are done. We have iterated through the points, and here is where we construct our output, right? So I have a simple for loop here that basically iterates through every element inside the priority queue, and the output, I'm just pushing back the top, but the second, right? The second is the points, which is what we want. Okay, once that is done, our output will look like this. The list inside 2, and then it will return the output -2, 2, which is exactly the same as the example given, right? Okay, let's do one more since that was relatively short. Let's do one more. Okay, same thing as before. So we got the first point 3, 3. So this will be 3 times 3, 3 times 3. Right. Okay, so basically this will give us 9. 9 plus 9 is 18. Next we have 5 and -1. Let me group them up together so it's easier to see. Actually, I think I'll just leave it as it is. Okay, so 5 times 5 plus -1 times -5. Okay, so this will give us 25. It will give us 1, which is 26. Okay, which is above. Next is -2 times -2 plus 4 times 4. Remember, we have to do this for every single point over here. So this will be 16. This will be 4. Total is 20. I put the point in 2 and 4. Okay, so let's sort it a bit. It will look something like this. Since k is 2, when we enter the third point, we have to pop it, right? So we pop this, we construct the output, which will include the -2 and 4 and 3, 3, right? Exactly the same as the example given, just that the order is different, but that's fine because we can return the answer in any order. Okay, pretty straightforward. That's all I have to show. Thanks.